to be there online academic tutorial. Today I will be considering Physics Jamb 2010 solution question 11 to 24. Now I'm going to be considering what? The solution to question 11 to 24 today. So if a wire 30 cm long is extended to 30.5 cm long by a force of 300 Newton, find the strain energy of the wire. Now to calculate the strain energy of the wire. So now we are given that what? A wire 30 cm long is extended to 30.5 cm by a force of 300 Newton. Given that what? The initial, which is the L naught, is equal to 30 cm. And what? And the new what? New length now as a result of the force applied to it, as a result of the force applied is what? 30.5 cm. Now you can calculate the extension by finding the difference between the extension E, by finding the what? Difference between L1 minus what? L naught, which is equal to 30.5 minus 30. Don't forget they are both in what? In centimeter. So we are going to have what? This is equal to what? 0.5 centimeter. So 0.5 centimeter is our extension. Now you need to take that 0.5 centimeter to what? Meter by dividing it by 100. You divide it by 100. So divided by 100 now, we move this one 1, 2. So it's going to be 0. Answer is equal to 0.05 meter. So that's the what? The extension. Extension is what? E equal to 0.05 meter. Now the question now says calculate the strain energy. Now we're talking about strain energy. The strain energy of a wire is calculated using what? E is equal to half Ke squared. That is what? Energy in a what? In a strain wire. So now, but this where K is what? Is the force constant, and K can be obtained as what? As can be obtained by F all over what? E. So from the Hooke's law, who says that what? F is equal to Ke. So K can be given as what? Can be obtained from Hooke's law, which is F over what? E. So therefore we have E, which is the strain energy, is equal to what? 1 over 2. Now when you substitute F over E for what? For K, what we have left here, we are going to have what? F over E multiplied by what? E squared. So this E will cancel what? One of the E. So the formula I am going to here is half Fe. So half Fe now is going to give us this half Fe. So it's going to give us 1 over 2 times 300 times what? Times 0.005. So when we multiply this one together, what do we have? So 2 here 1, 2 in this 300, we have 150. So 150 times 0.05. So our energy is equal to 150 times what? 0.005. We can swell what? So what would that one give us? When we multiply it, give what? 0.75 what? Joule. So the answer here is 0.75 joule. Option what? D. So you can see that what? The strain energy is given as what? K half Ke squared, and you can also write it as what? Half Fe. So substituting now, we are going to have what? E is equal to 150 times 0.05, so which is what? 0.75 joule. So that's that option what? E. Now 12. In an hydraulic press, the pump pistons exert a pressure of 100 what? Pascal. Please follow, this is 100 Pascal here on the liquid. What force is exerted in the second piston of cross-sectional area 3 meter square? Now we are told that in a hydraulic press, the pump exerts a pressure of P equal to 100 Pascal. We call this one Pascal. That's one of the units of what? Of pressure. So 100 Pascal on a liquid. What force? Now we have to calculate the force is exerted in the second piston of the cross-sectional area A. which is equal to what? 3 meter per seconds. 3 meter per second. So sorry, 3 meter square, which is equal to 3 meter square. So what is the what? The force exerted in the second piston of cross-sectional area 3 meter square. So from the formula of what? P equal to force over what? Area. That is, pressure is equal to force over area. We are asked to calculate the force. Now meaning that what? By cross multiplication your force is equal to what? Pressure multiplied by what? Area. Don't forget that what? The pressure of the first piston, that is the pump piston, will be equal to the what? To the second what? Piston. So that's why we are using what? Pressure equal to what? Force over area. So they are the same thing. Pressure is equal to force over area, and force is equal to pressure times what? Area. So your force here will be equal to, now your pressure here is 100 multiplied by your area, which is 3 meters square, so which is 300 Newton. 300 Newton. So the answer here is 300 Newton. Option what? D. Option D. So that's that about that. Now the accurate measurement of relative density of a substance in its powdery form, in the powdery form, is done with a beam balance, and is done with a beam balance. Now the accurate measurement of relative density of a substance in a powdery form is done with a beam balance and a density bottle, and a density bottle. We use density bottle to measure the relative density of a substance. Density bottle is it looks like this. It has a cork on it. Now something like this. This is how the density bottle look like. So it is used in under 20 degree Celsius room temperature, 20 to 25 degrees Celsius. So this is what we call density density bottle. So please take on. A hydrometer is an instrument used for measuring. An hydrometer looks like this. You have a long, so at this bottom here it has like something like, so it has some, so and it has a calibration on it that will help us to measure. So this is what an hydrometer. So now number 15 says, one special advantage of alcohol over mercury as a thermometric liquid is it does. Number 15 says, one special advantage of alcohol over mercury as a thermometric liquid is it what? Now, what is the advantage of mercury over what? What is the advantage of what? Alcohol over mercury as a thermometric what? Liquid. Is it low freezing what? Point. It is low freezing point. So option what? A. Now, when I talk about low freezing point of alcohol, alcohol has low what? Alcohol has low freezing point. Has low freezing point below 100 degree Celsius, below 100 minus 100 degree Celsius. So now it has, alcohol has low freezing point below minus 100 degrees Celsius, about approximately minus 170 degrees Celsius precisely. So but below 100, it means that it can measure what? It can measure a temperature below what? Below minus 100 degrees Celsius. So that's why it's an advantage. It's one of the advantage of what? Or it has over what? Over mercury. It's one of the advantage that alcohol has over what? Mercury, because it can measure what? A temperature below minus 100 degrees Celsius, meaning that it has low freezing point. Option A. Please note that option A, it has been marked here. So it is option A. So that's that about that. So now the next question here says, two metals P and Q of length L1 and L2 are heated through the same temperature. They are heated through the same temperature. Okay, question number 16. Two metals P and Q of length L1 and L2 are heated through same temperature difference. if the ratio of the linear expansivity of P to Q is 2:3 and the ratio of the length is what? 3:4. What is the ratio of increase in length? Now we are given that what? 2 meters. 2 meters, we are given 2 meters P and what? And Q. We are given 2 meters P and Q. So P and Q. And we are told that the length, you can write the length here, the length of P to the length of P is what? Is L1 and the length of what? Q is L2. And we are told that what? The ratio of the length, if you look at this one, the ratio of the length is 3 to what? 4. So meaning that if this is what? L, if this is L1, it means that this is 3L1 and this one will be what? 4L1. So it is what? 3 ratio what? 3:4. So 3, if this is 3L1, this one will be 4L1 because they say it's 3 what? 3:4. Now we are told also that they have the same what? Same temperature difference. So they have what? Change in temperature is the same thing. So the change in temperature is change in theta, change in theta. They have the same change in what? In change in theta. So that is temperature difference. So we use change in theta for it. Now, and also if the ratio of the what? Expansivity, the ratio of the linear expansivity is 2:3. Now if this one is 2 alpha, this one is what? 3 alpha. Please note that. So the unit of linear expansivity is what? The symbol for linear expansivity is alpha. So if this one is 2 alpha, this one is 3 alpha. So now we are now asked to what? To calculate the ratio of its increase in length. What is the ratio of the increase in length of L1 to what? Of what? What is the ratio of the increase in length of P? Let me use what? Increase in length of P to ratio of what? Increase in length of what? Of Q. Now what is the ratio of increase in length of P to what? Q. So that's what we are asked to what? Calculate. Now how do we go about it? We know that what? In linear expansivity is given, linear expansivity of the material is given as what? Change in length all over original length times what? Temperature rise or temperature change. So this is the formula. Now but we are looking for what? The ratio of the change in length. So we make this change in length formula. So by cross multiplication we have what? Change in length is equal to what? Alpha multiplied by what? L0 change in what? Theta. So I have multiplied this one together, so it's change theta. So we have what now? So here now we can now substitute our values now. And how do we substitute our values? We say that what? Okay, for L0, for L ratio what? For L change in LP all over change in L0 change in LQ, please follow, which is equal to what? Now, to write change in LP now, we are going to have what? Now, the linear expansivity for LP, for P, under this one now, with what? The expansivity is 2 alpha, so we have 2 alpha multiplied by L0. What's our L0? The initial what? Length. The initial length is what? The initial length of this one is what? 3L1. So we have what? 3L1, the length. So 3L1 minus what? Times what? Times change in theta all over. Now we have all over 3 what? 3 alpha multiplied by now we have 3 alpha multiplied by 4L. L1, we have 4L1 here under Q. 4L1 under Q multiplied by change in what? In theta. So now let's cancel that now. So this one cancel this. We have L cancel what? L1. L cancel L1. We have 3 here. Also cancel this 3 here. We have the linear expansivity here, which is alpha, cancel alpha. Then 2 here, 1, 2 in 4, we have 2. So we have change in LP to what? Change in LQ is equal to 1 all over 2. Meaning that what? The answer is what? 1 ratio what? 2. Final answer. So the answer is C, option C. So that's that about that. Question number 17 says that the density of a certain oil on frying becomes what? 0.4 kilogram per meter cube with a volume of what? 20 meter cube. What will be its initial volume when its initial density is what? 0.8 kilogram per meter cube, assuming no loss of oil due to the what? Due to the spillage. Now we are told that what? The density of the oil while frying becomes 0.4 kilogram meter cube. Now the density rho, this density rho while frying is equal to what? 0.4 kilogram 0.4 kilogram per meter what? Per meter cube. 0.4 kilogram per meter cube. Then its volume while frying is what? Its volume while frying is equal to what? 20 meter cube. And its initial volume, it said what will be its initial volume? We have to calculate the initial volume, which is VI or no. If its initial density, calculate what will be the initial what? Volume. If its what? Initial density is what? Now we have to calculate what? The initial volume when the initial density I is equal to what? 0.8 kilogram per meter what? Cube. So assuming no spillage of oil during the process of frying. Now the first thing you need to know is that the mass is constant, because we are told that what? No oil spillage. So we need that the mass of the oil is constant. So we need to find the mass first. So we know that what? The density of a substance, which is density of the frying oil, is equal to mass. Since the mass is constant, mass remains the same. So mass over what? F over V. Now the density of a frying oil is equal to mass over the volume of a frying oil. So meaning that what? Our mass now will now be equal to what? Density of the frying oil multiplied by the volume of the frying oil. So now what will be our mass now? So we have 0.4 multiplied by what? 20. So which is equal to, when you multiply this one together, this is going to give you what? 0.2 multiplied by 20 is 0.2, 0.4 multiplied by 20 will give you what? 8. So we have 8 kilogram. 8 kilogram. So the mass here is 8 kilogram. The mass is 8 kilogram. So since we have gotten the mass and the same mass, we are told that the mass of the what? Oil remain constant because there is no oil spillage. So we can now use that for subsequent what? For the initial, we can use the mass obtained now for the initial volume. Now, meaning that, okay, since we have obtained what? The mass of the what? Oil to be 8 kilogram. Now we can use it to obtain the what? The initial volume. So the initial density now is equal to what? Mass all over what? All over initial volume. Then initial volume will be equal to what? Mass all over what? Initial density. You just make this what? Volume the subject of the formula. So when you make subject of the formula by cross multiplication, you have what? Initial volume equal to mass all over what? Initial density, which is equal to, now what's your mass? Your mass is what we just calculated now, which is 8 all over. Then the initial density is 0.8. This is initial density here, 0.8. So 8 divided by 0.8, what do you have? 8 divided by 0.8, you are going to have what? 10 what? Meter what? Cube. So 8 divided by 0.8 is what? 10 meter what? cube. So option A is our answer. So note that. Question number 18. Question number 18 says that heat is radiated by all hot objects in form of A. Light energy, B. Solar energy, C. Infrared ray, D. X-ray. Now, heat is radiated by all hot objects in form of infrared rays. Infrared rays. What are infrared rays? These are electromagnetic rays, which is between what visible light and microwave. So it is in between what the visible light and microwave. So infrared ray is a form by which heat is being radiated from what? An hot object. So that's that. So note that infrared is what is the answer. So that's that about question number 18. If a container is filled with ice to the brim, what happens to the level of water when the ice completely what melts? Now, when a water is filled with what? When a container is filled with what? With ice to the brim, we have what? When a container is filled with what? Ice to the brim. Then I say now, when it melts completely, what will happen to the level of water? Now, what will happen to the level of water? Will the water overflow or be at the same level? So now what will happen when this ice in the water here, when it's melted, what becomes of the water? What becomes of the water? So now what becomes of the water is that the water still remains in the same level, because when you put an ice inside the water, the ice what? Displaces the what? The water to support itself. So when the ice completely dissolves in water, now it does not change in level of water, because the ice has already displaced its what? The water initially. So the water level remains the initial what? Level before it what? Before it completes what? Melting. So the initial level of water remain what? The same even after the complete melting of the what? Of the ice. So let's check the option. The water in the glass at flow? No. The level of water drops? No. The level of the water remains unchanged. That is option what? C. Please take note of that. The level of water remains unchanged because the ice has already displaced the what? The water before it even met in the first place. So after melting, it retains the level of the water. So that's that about that. Question number 20 says the small droplet of water that forms on the grass in early hours of morning is dew. Dew. So option A is dew. This is option A. So that's the small droplet of water that forms on the grass in early hours of the morning. So number 21, a vapor is said to be saturated. A vapor is said to be saturated when a dynamic equilibrium exists such that more molecules return to the liquid than are leaving it. The vapor pressure is atmospheric. The temperature of the vapor varies. That's option C, no. And D, a dynamic equilibrium exists between liquid molecules and the vapor molecules. Yes, this is very, very correct. So our option here is option D. Now, when a vapor is said to be what? Saturated. A vapor is said to be what? Is said to be saturated. To be saturated. Now, if is in equilibrium, if this vapor is in equilibrium with its own liquid, now is what? A vapor is said to be what? Saturated when it is in dynamic equilibrium with its own what? Liquid. A vapor is said to be saturated if it is in what? Dynamic equilibrium with its own liquid. So that's why it is option what? D. So that's option D for you. Now question number 22. The pressure of 1 mole of an ideal gas, the pressure of 1 mole of an ideal gas of volume 10 raised power minus 2 meter cube at a temperature of 27 degrees Celsius is dash. The pressure of 1 mole know, we have to calculate the pressure of 1 mole. That is N equal to 1 mole. N equal to 1 mole. Then the temperature is 27 degree what? Celsius. Now you have to take this 27 degree Celsius to what? To Kelvin by adding 273 to it. So 27 plus 273 it gives what? 300 what? Kelvin. It's 300 Kelvin. And R, that is the molar gas constant, is 8.3 joule per mole per Kelvin. Now, knowing that this is an ideal gas, now using an ideal gas equation, which is PV equal to what? nRT. Now, P will now be equal to, that's P, we are looking for P, that's P equal to nRT all over what? V. Substituting what? The values that we have here, which is 1 mole multiplied by what? 8.3 multiplied by T, which is now 300 Kelvin all over. Your volume here is 10 raised by minus 2. Don't forget that the volume is what? Volume is given as 10 raised by minus 2. So the answer here is equal to, now when you multiply this, so and divide it by volume. I thought that the volume is 10 raised by minus 2 from the question. So 1 times 8.3 times 300 over 10 raised by minus 2. So what do we have here? 249,000 Newton per meter square. That's the unit of what? Of pressure, Newton per meter square. So when you press this on calculator now, we have what? 249,000 Newton per meter square. So when you take it to standard form, by moving this one 1, 2, 3, 4, then 5, we have 2.49 times 10 raised to power 5 Newton per meter square. So that's the pressure for you. That's the pressure for you. So which option is this? Option C, 2.49. So that's that about that. Now, which of the following has no effect on radiation? A, density. B, temperature. C, surface area. D, nature of surface. Now, we are talking about radiation. Radiation is a form of what? Emission of heat from a substance, and it is affected by temperature, the surface area, and the nature of the surface. Maybe it is black, white. It is affected by the nature of surface. So the only thing that has no effect on radiation is what? Is density. Density has no effect on radiation, but temperature affects radiation, the surface area affects radiation, and the nature of surface also affects what? Radiation. So that's our number 23 question. So now the last question here says the wavelength of a wave traveling with a velocity of 420 meters per second is what? 42 meters. What is its period? Now the wavelength lambda is given as 42 meters, and the velocity of the wave is what? 420 meters per second. Now what is its period? T. Now knowing that what? The wave speed is given as what? Lambda times what? F. Note that the wave speed is given as what? V equal to lambda times what? F. So here we can easily calculate our what? Our frequency. Then frequency is equal to what? V over lambda. Now which is equal to 420 all over what? 42. So that's 420 over 42. So we have, this is 10, exactly 10 hours. So to get our period, just say T is equal to 1 over F. That's the formula relationship between period and frequency. So 1 all over what? 10 is equal to what? 0.1 seconds. So 0.1 seconds. This is option what? Option B. So we have come to the end of today's what? Solution to question 11 to 24. Please do well to subscribe to this what? YouTube channel in order to see all of the solution on this what? Channel. Thank you and God bless you.